Hey everybody, it's Krystin over here at Leeman Geophysical. Today we're going to be doing a tutorial on soldering. I won't be giving the tutorial, we're actually going to have Jonah come in and teach us. I've never done it before, so he's supposed to have all of the tips and tricks and tell us what on earth we're doing. So if you're brand new to it also, go ahead and stick around.
So today we're going to be going over the basics of soldering, a little intro for anyone that's just getting started or needs to do some quick fixes on their equipment or anything like that. So we're going to do a quick overview of what kind of equipment might be necessary, what you want to have on hand. Let's just start with some of the basics. So for a soldering iron, I like to use a benchtop iron set to around 380 degrees Celsius. There are a lot of different types of irons you can get. There are portable ones that run on propane, but usually a benchtop power supply like this for your iron is going to be your best option for any work that you have to do in the lab. So this one's just kind of a cheap one, but it's reliable. You can get them on Amazon. Then for your hand tools, we have 3 different hand tools that I recommend you always have. We have some smooth jaw pliers for bending wire leads or anything like that, some flush cutters for clipping off the extra wire off of components, and then just some wire strippers for stripping any wire that you're using. Then for the solder itself, there's again a lot of different types of solder that you can use, different wire gauges, different alloys. We typically use all lead-free solder. Leaded solder tends to work a little bit better. You can rework it a little easier, but lead-free solder works just as well with a little bit of patience. I've got 2 different sizes that I use. I have quite a thick solder that might not be the best for beginners, but I do quite a bit of soldering and you can get joints done quite a bit faster with this. It also has a lot of flux packed into it. And then you have much thinner gauge, which you end up having a lot more control over how much solder you're feeding into the equipment or into the joint that you're trying to make. So I use both of these depending on what application I'm trying to do. And I mentioned that it has flux inside of it, but you can also get external flux that you can apply to your joints. There's a bunch of different kinds of this as well. I use mainly rosin-based flux. It's not quite as corrosive as water-based flux, and it works very well. It can fume up a little bit more, but you don't have to clean it necessarily. It's recommended, but it's optional. It's not as conductive as water-based flux. We have a pen variant of it that works just kind of like a paint pen. You can push it down and get all the flux into the tip and paint it over the components that you're about to solder. Not necessary, but definitely helpful. And then we have a few different tools for desoldering. We'll get into these a little bit later, but the 2 ones that I use the most are desoldering wick and a little desoldering pump. So I think we'll now go into some up-close shots of how to do some solder joints, and we'll have Krystin try some solder joints as well. So yeah. Okay, so today we're going to be doing some through-hole soldering. It's some of the more basic soldering that you can do. There's also surface mount, but in this video today we'll be primarily covering through-hole soldering for any components that have metal leads that actually stick through the circuit board and then you make the connection on the back. Surface mount components are just metal pads that you would place your component onto and then solder to that pad. So basically soldering is just making an electrical connection with a low melting point metal alloy, usually made of tin and silver or copper and lead, different alloys. But today we'll be using a tin, silver, and copper alloy. So with any component that you want to solder, it can either be polar or non-polar, which just means that the orientation either matters or it doesn't matter. With basic components like resistors, most of the time it doesn't matter, but we're going to be soldering some LEDs, which do have a polarization. And so you can look at them and see they have a little flat spot on the little rim here. It's kind of hard to see, but more obvious than that is the shorter lead and the longer lead. And so on the board you can see there's a little silk screen ring around where we're going to be soldering this LED, and there's a little flat edge along the end here, and that usually lines up with the flat edge on the actual LED. So we will line that up with the flat side on this LED footprint, which is also in line with the shorter leg. So as long as the shorter leg goes towards this flat edge, we should be good. So we'll stick it through the board just like that. And if we were to turn it over, it'd probably fall out. So I'll hold it here and I'll bend these legs in opposite directions. And that just kind of helps to keep everything held down and in place. We've got 2 pads here that we're going to try and make the connection to. We'll start with this pad on the outside edge. So with some irons, they can kind of corrode and the solder does not melt on them quite as well over time. So there's a couple different techniques you can use for cleaning up your iron before you start. So typically I start with a little Brillo pad like this, and I'll just scrape the iron to get it a little cleaner, get any excess solder that's been left on there from the last time, get all that off. And then I like to use this stuff called tip tinner, which is basically a mix of ground up solder and flux, and it does a great job of cleaning and making the tip look nice and shiny again. So just a quick sweep through there, makes it nice and shiny, and then just a quick rinse on the Brillo pad again. So now that our iron is prepped and ready to go, I'm going to take a bit of the thicker solder here and unwind just as much as I need to make these joints. And so the basic idea is that you'll take the tip of the iron and place it so that it's touching both the pad that you want to make the connection to and the wire. You want to heat both of those up with the iron. So we'll take the tip of the iron and place it into that connection, start getting both of those hot, and then we'll feed a little bit of solder onto that connection. It doesn't take a whole lot with this thicker stuff. And then hold it for just a second and pull it off. And you can kind of see it makes a nice little cone around the connection wire and the pad. So that's basically just bonds to each piece of metal and makes a solid mechanical and electrical connection. We've got all this excess wire on the end, so we can take our flush cutters and just clip away right above where the solder ends. Not too close, we don't want to cut away the solder we just put down, but just right above it so you're left with a nice cone of solder around that connection.
Maybe you said this, but how do you know which size you use? Or does it matter? Is it just preference?
It's kind of just preference. So with bigger solder, you have more flux in the core, so making a bigger connection can be a little bit easier. And you don't have to feed nearly as much when you're working with a thicker solder like this, but you lose a little bit of control. So with practice, you can use this thicker solder quite effectively, get a lot of joints done quickly, but you'll have a little less control and it's a little easier to make mistakes. So with this next solder, I'll do the next joint with this stuff so you can see the difference. So with that, I barely touched it, just a few times. With this, it's significantly thinner and I'll need to feed in quite a bit of this solder to get the same kind of connection. But then again, you have more control. You can feed as much as you want to and just have a little bit more agency on how much solder is going into the joint. So I'll do the same thing again, placing the tip of the iron into that connection to heat up both the pad and the metal lead. And then I'll feed a little bit of solder into it. You can see I'm going quite a bit deeper with this thinner solder. And then when it's done, I'll pull it off. So we get the same kind of joint, it just takes a bit more action. And again, we'll clip the excess off here. And there we go. That's one component fully soldered to the board. What we want to avoid doing with a connection like this, where there's multiple leads on the same component, which there almost always is if we were to feed too much solder, it's really easy to make a bridged connection between these two LEDs. I'll show you what that looks like and how to fix it, because if you solder enough, it'll eventually happen. So it's good to know how to remedy that situation. So let's say I was using this thicker solder and I was touching up this joint a little bit. I maybe got the iron a little too close to both connections and I fed a little too much solder in. We get a joint between the two connections. So that's bad. We don't want to do that. But if it happens, it's not the end of the world. As long as everything is powered down, nothing bad is going to happen right off the bat. But you can see that these two are now connected by that little solder bridge. So to fix that, one of the easiest things you can do is just clean off your iron, get all the solder off of it, melt that connection and just drag away. Some of the excess solder will be stuck to the iron. You can clean it off. You can do this a few times. If things start to get sticky and the solder isn't quite flowing as well, you can add a little bit more flux to it to get things flowing nicely again, but I'll show you what that would look like. See, it only took one pull to break that little bridge. and I can clean off the iron. If it was still there, I could do that a few times, remove that solder just onto the tip and clean it off and onto the tip. Sometimes it doesn't work quite as well, so I'll show you another technique you can use, making that bridge again. So there are a couple different tools we've got for removing solder. In general, making connections is pretty easy. The hardest part about soldering is usually trying to remove it after you've already put it down. So what I would probably use in this situation, since it's all just on one side of the board that we need to remove solder, would be this solder braid here. And what this does is it's essentially just a braided mesh of copper wire, and it does a really good job of sucking that solder into it, almost like a paper towel wiping up water, but you need to apply heat to it. So what I would do is I would put this, make sure the iron is super clean. Sometimes it's even helpful to tin the iron, which is putting a little bit of solder onto the iron again before you start. I would place this over that connection and then place the iron down onto it. You can see it wicks all that solder up. And so if you have a bigger bridge, this is a really great way to remove a bridge that way. That one's pretty easy. It's just a two lead component. So pretty easy to make a joint like that. Let's have you give it a shot.
Okay, so we're putting it in there, and then you said kind of bending them.
Just bend them in opposite directions to make sure it's nice and locked in place.
So first you do this. Oh, that is warmer than I thought it was gonna be.
Yeah, don't want to hold it like a pencil or you'll burn your fingers.
Right.
Hold it a little bit back like a paintbrush.
Makes sense. Is it quick? Does it matter?
You can hold it in there, it'll clean it. As the heat melts that flux and the flux burns, that's what causes the chemical reaction that actually cleans the metal.
That was really satisfying.
Yeah, it is pretty fun.
So you're just making sure you don't have any of this stuff on it still?
Yeah, as long as it looks nice and shiny and silver, it's probably good to go. For a beginner, I would honestly recommend something in between these two. I primarily use the thicker stuff if I'm doing a ton of big joints that I need to do quickly, and I use the smaller stuff for like micro soldering when I need to solder to the edge of like a very fine pitched component where the pins are really close together and I need that fine control. I'll use the thinner stuff. But for a beginner and most joints, I would find something in the middle of this. One quick safety tip. It's not quite as important with this thinner stuff because it does not conduct the heat as well, but you don't want to hold too close to the tip because the solder itself will actually heat up and you can burn your fingers a little bit if you're holding too close. So holding it just a few inches back is a good way to just prevent that from happening.
So you said heat it up first, right? Both of, like the little circle part?
Yes.
And that?
Yeah,
Okay.
so you want to be heating up both the little pad and that little metal wire there that you're trying to connect. So you'll put
And you
it
said get this in your hand to be ready?
Yeah.
Okay. I'm so stressed. How long do you have to touch it?
Not too long, but it's better to hold it there a little longer than not long enough.
So you don't really know when it's hot enough though?
Yeah, and you can kind of start touching the solder to it, and when it's ready, it'll start to melt.
Okay.
So that's kind of how you can know. It's a pretty flexible process. It's not too strict in how it goes.
Okay. What, do you need to move it around or?
So what I typically do is first melt a little bit onto the iron and then move it down into the connection. And that just helps the iron start to heat that even better because that solder that's on the tip of the iron will help conduct the heat into the connection that you're trying to make.
So start kind of up on the iron and then move down into it?
That looks perfect. That's ideal. You couldn't get a better joint.
And we're supposed to clean it before I put it back in there?
Ideally, yeah, it's always a good idea to clean it off. And some people like to tin their irons and then put them away, and that solder that's on there kind of helps protect it from oxidation and that kind of thing. You can then clip it right above that cone that you made. And so now you've got solder on one joint. And so to do the other one, it's going to be a little trickier because you don't want to remelt that because then you run the risk of causing a bridge as you feed more solder into it. So for this next joint, I would try and come in on the side of it and try and avoid remelting this joint if you can.
And try it with this one this time?
Yeah, give it a shot, see what you think. With that one, you only need like that much off the tip. With this one, it's like an inch, but with this one, you don't need much. And if all the components are properly hot and ready, you'll see that the solder will naturally bind to the metal. That's called wetting. It will flow out to the full surface area of whatever metal it's touching or whatever metal is hot. It's a nice indicator that it's getting a good joint if you can see that solder actually flowing out into the full.
Okay. This is so stressful.
You'll really quickly realize soldering that you need to have at least 4 hands.
Yeah, it feels like a lot. I can't even see, the smoke's coming into my eyes.
Yeah.
Is that coned enough?
That looks perfect.
Okay.
Good job. Yeah, that's exactly what you're looking for. You didn't get any bridges, you made nice cones, the pads are fully covered. It means you got just the right amount of heat and the right amount of solder, so good job.
Should I bridge it though so I can practice?
If you want to try, yeah.
Because I know as soon as you leave and I try the pumpkin one,
it'll probably happen.
I'm going to bridge it.
Inevitable.
Okay, so I can just add some on here.
And you can clip that extra wire off the second joint if you
Oh,
want to.
shoot, yeah, I did forget that. It's hard to tell where the cone thing ends. Oh, wait, I see it. Okay.
Usually I kind of clamp down over the wire and slide down till I feel the resistance of the tip of that joint.
Makes sense.
You can kind of see here, they're pretty close to that cone. So you can try this however you want. If you want to just try the dragging method.
First one was dragging. Okay. So you just kind of... Wait, you did say do this, right?
Mm-hmm. Yeah, you'll kind of put it flat over it and then just pull down, and that extra solder. It might take a second for all the solder to melt.
I was like, it is not.
If you come at it with the flat side of the chisel.
Oh, wait. Okay, like that.
Yeah, it'll transfer that heat a little bit.
Oh, yeah, wow, that really did. And I pull down?
I think you got it.
Okay.
Perfect. We still had some of the flux left from the last time we soldered it, but the more that you rework the joint, the more that flux will burn away. And without flux, the solder will start to become kind of clingy, and it will create little spikes, and it'll stick to your iron, and bridges can be harder to fix. So if at any point you feel like the solder is starting to get a bit gritty and sticky, you can re-add that solder, or re-add that flux with the pen, or if you need it, or you can just paint that over the connection.
I forgot the flux part that you said. Wait, where?
So the solder itself has flux in the core.
Oh, okay.
So as you solder, that flux is melting into the joint, and you don't need the extra flux. But as you rework the joint, like if there was a bad bridge or something, that flux will start to evaporate. And it starts to get more clingy and just harder to work with in general. So that's when you would come in with the extra flux, and you paint over the connections.
Okay, so you would just like put it on the part that you're working with?
And with these big components where they're pretty spaced out, it's not as important. It's still very helpful, especially when you want to get nice, clean-looking joints to have that flux. But when you're working with really fine-pitched components where all those connections are really close together, it's really easy to get bridges between all those pins. And the flux helps the surface tension to pull that solder onto only the metal so that the bridges don't happen as easily. It makes it much easier to just swipe your iron and have the solder stick where it's supposed to, if that makes sense. It's kind of magic. So we got 2 LEDs soldered. You did a really good job. We'll just get a little bit more practice with a different kind of component. So this is an integrated circuit called an op-amp. What it does isn't too critical to the demonstration, but it amplifies some signals. So it would go into a footprint that looks like this. And this is also a polar component. So it has a specific orientation that it goes to. You can kind of see on the tip of it, it has that little notch right there. So that would match up with the notch in the silk screen. And sometimes it's not super obvious what the indicator was. Like in some situations, you might not have a notch on the component, but there might be some other indicator. In this case, you actually have 2 indicators. So that little divot right in the corner, that's the pin 1 indicator, which usually the identifying mark on both the silk screen and the component will point to the first pin of the component, which is labeled in the data sheet for the component. So you can kind of just match up. Looking at the data sheet, if you're not too sure, where is pin 1 on here, and usually on the board you can find some kind of indicator of the pin 1. So in this case, we'll be matching that notch to this notch, and we'll be putting all 8 pins into all 8 holes on the board here. Place it in, and this is actually just a hair wider than what's on the board, so I'm going to take it and just kind of roll it forward to bend those legs just a little bit, get them a little closer together so that it fits nicely into these holes, just like that.
Question. How do you know if it's polarizing or not?
If you're unsure, you can always look in the data sheet and see if they have a pin 1 indicator. Most of the time with a complex component like this, they are almost 100% going to be a polar component and have some kind of indicator to show you that. In situations where you have a 2-pin component like the LED or like a resistor or a capacitor, usually there's some kind of indicator on the schematic you're looking at or on the actual component if it's polar, but most of the time 2-pin capacitors and resistors are not polar. So it kind of takes a bit of practice, you know, get exposure to a bunch of different kind of components. But for whatever you're working on, you can always refer to the data sheet for the component and just verify that information if you need it. And in this situation, the component legs are quite a bit shorter, so it's a little more difficult to bend it, to hold it in place. But if you need to do that, sometimes I'll just hold it with the back of my finger and take my nail and roll these pins over just to really lock it in place before I solder. Now it's not going to come out of there. Also, sometimes you can hold the back of the component and make your first connection. Again, that takes a little bit of coordination to hold the component, hold the solder, and hold the iron. So if you can't do it with your fingernails, sometimes you can take a pair of smooth jaw pliers and roll those pins over just to hold them in place if you need to. But whatever works for you. The only thing I would be cautious of is some components will get quite hot as you're soldering the pin. So I would, if I was going to hold this in place and solder the first pin to stick it in place, I would do it quickly so that I don't accidentally burn my finger. In this case, we just rolled it over so it's locked in place. So this is the same idea, except we've got 8 pins. So it's going to take a little bit more time, but as you get the feel for it, you'll get a little bit faster. And I'll do the same thing coming in from the side, heating up that joint, feeding a little solder into it, and then just pulling it away. As you get more practice, you'll get a little faster at this. I'll just do one side and then have you do the other. Just like that. So again, these connections should look kind of like little cones. You should have full coverage over the pad. This joint on the right side looks to have not quite enough solder for my liking, so I'll just touch it up again, cleaning off the iron and feeding just a little bit more solder into that connection. Can help too if you want to get nice pretty joints to, as you remove the iron, pull it along the metal lead, and that extra solder will get pulled up and make that nice cone shape for you. Sometimes if you pull it directly away and you've burned away a little bit too much of that flux, you can end up with a little spike jutting off the side. It's still perfectly functional, but it's not the prettiest, so.
Ah, it's stuck.
Sometimes that'll happen. If you pull, you always want to pull the solder away first and then the iron. Okay. It can sometimes cool down and your solder will get stuck, but you can always just remelt it. It's no big deal.
Oh, yeah, that's stressful with them that close to each other like that.
It can be a bit tricky. The irons themselves have different tip shapes. This specific one that we're using is a chisel tip, which is quite a big tip. And it transfers a lot of heat really quickly. You can make joints fast with it, but you have a little less control over where you're soldering. So there's a few trade-offs to the type of tip. Some of them have a very fine tip, which you can use for soldering tiny components quite well. Those look perfect.
Cool.
Good job. So the last thing we'll go over today for through-hole soldering is if you wanted to solder wires to a circuit board. It's a little bit different just because the wires are flexible, you can't lock them down in place, so there's a couple tricks that you can do to make things a little easier. So we'll solder this little battery clip for a 9-volt onto the pads here. This specific circuit board has some extra strain relief holes, which not all boards will have, but ones that do, it's kind of nice. It prevents pulling on the wires and ripping them out of the board just by adding that extra little bend. So here we have a negative and a positive input, and most of the time in the States, the black wire is usually negative and the red wire is usually positive. So we'll feed the red wire. Before we do that, let's actually get this prepared, because right now we can't see that internal wire, we can't solder to it, it's all covered in that insulation. So we'll take the strippers and we'll remove just a little bit of that insulation off the wire. And for this particular wire, it looks to be around 24 gauge wire. So on here you can see there's different numbers for the different gauges of wire, which is essentially just how thick the wire is. If you use too small of a cutting edge on a bigger wire, you can actually accidentally cut into the conductors and you lose some of the wire in there. So you want to always use the right hole size for the right wire. So I'll just lightly pinch around the 24 section and just pull that off. You can see we exposed the internal wires. What I like to do is then give them a twist just to make sure they're nice and bound together. Makes a nice solid point. And at this point, you could go ahead and make your connection and solder it like normal. But if you want to go an extra step further and make it just a little easier on yourself, you can do what's called tinning the wire, which is actually feeding solder into this wire before we solder it, which will help things flow a little nicer. It stiffens this up so it won't bend in a way you don't want. So I'll clean up the iron here. And as you can see, I've got kind of a funky grip going on here. I'm holding the wire in my index and thumb, and then the solder back here. Sometimes, if you're not as comfortable doing that, you can get what's called a third hand, and they come in a lot of different shapes. And so with this, you could hold the circuit board down so you have a little bit more freedom. It's not trying to move around on you while you're making solder connections. And some of them have little alligator clips that'll, you know, I could clip this wire in there so that I can just hold the solder and the iron and make that tin on the wire. But since we've got just our hands here, I'll just do this little technique. What I like to do is take the iron, place it under that wire to start kind of getting the wire hot, and I'll feed a little bit of solder onto the iron and just run it along. With a bigger wire that's copper, so it's a different color than the solder, you can actually see that solder start to flow into the wire, and it looks pretty cool. But if you feel it now, it feels like one solid strand, and it's quite a bit tougher. As opposed to just all the fine little strands.
Okay, you said 24? Is that far enough?
And just clamp and pull it off. A little twist to make it nice and straight and sturdy. And if you don't want to do that weird clamp, sometimes you can just bend the solder so that it's stable and then hold the wire and kind of just feed it up into it. Okay. Sometimes a little easier.
You just touched it like that. And then kind of carried it up? Yep. Is that what you did?
That looks perfect. Okay. Our next step is going to be to feed it up into the board. So like I said, this one has the extra strain relief holes. If it didn't have that, you would just feed these wires directly down into the pads like so. And then you would make these connections.
What you said, if it what?
If it doesn't have these extra strain relief holes. So basically the way this works is that you feed it up through these holes first. The whole wire goes through. And then you would bend it down into the hole. And so what that does is it adds just a little extra retention on the wire so that if it gets pulled, it's tugging on the insulation, and up here it just disperses that load a little bit across so that it's less likely to break right off the board. But like I said, if it does not have those strain relief holes, which a lot of circuit boards don't, you could just go straight to the pads. Gotcha. But since we've got them, we'll use them. And like I said, the negative goes to the negative, or the black goes to the negative. So we'll feed it up through that bottom hole, feed this up through the top hole, and then we'll bend these back down into that through hole connection. And I like to just bend them just a hair just to make sure they kind of lock in place. Now, some people like to do this a little bit differently, where they would actually melt solder into this hole, tin the wire, and then instead of feeding solder into the joint as they make the connection, they would remelt the joint and then just push the wire in, and the connection would be made all at once. I personally don't like doing that. Did you have a question?
So, okay, just making sure I understood what you said. They reheat the little circle part thing?
Yeah, so
then as they're pushing it, it melts
it all just melts together.
Okay.
So yeah, they would feed solder into the hole first.
Don't like, they feed, okay.
Yeah, and then they remelt it as they stick the wire into it. And when you pull the iron away, everything is solidified again.
But you don't like doing that?
Yes, and the reason I don't like doing that is because we don't usually use silicone wire. We use, PVC or some kind of plastic wire that melts pretty easily. And so if you do that, sometimes it can start to melt that insulation and jam it into the hole, and then it starts to get dirty, and it's harder to make a good connection if you start melting insulation into the connection. I like to do a method where you just stick it in, and you do it pretty much the same as we did the LED. So I stick it in, the insulation is thicker, so it's not going to go any further as long as things aren't hot, and I kind of just bend that wire down to hold it in place, and I'll do just the same as we did with the LED, cleaning the iron, heating up both connections, and then feeding a bit of solder into the joint and pulling it up. And so we get that same nice kind of cone, and we can take the flush cutters and cut off any extra wire that we have. And just like that, we've soldered the wire straight to the board.
Put it through. Yeah.
Looks perfect.
Okay.
You can clip off the
Cut
extra
it.
wire. So there's all of some of the basic techniques of through-hole soldering. It's really not too complicated. It can be a bit intimidating at first just because you're working with hot tools and molten solder, and it all sounds worse than it really is. But that was a good little intro into making some of these connections. The last thing I want to go over is removing solder from these holes if you needed to replace a component. So I'm going to pull out these wires, and you'll see that the solder will be left kind of clogging the hole. And so I'm just going to pull this back a little bit so I can get a nice grip on it and pull this wire out just by remelting it and giving it a bit of a pull. So you might need to do this if, say, one of the wires broke and you needed to replace this little connector, or if an LED goes bad or something like that, you could, touch the iron to both sides of these and melt it and then kind of pull it off. The only downside to what we did earlier by bending these leads is that it makes it a little harder to remove should the component burn out or need replacing in that way. So in that situation, sometimes it can be helpful to grab it with a third hand. We don't have one with us right now, but a heat gun is super useful for doing rework like this. You can just take the heat gun and melt all those connections, and with a pair of pliers you can pull the component right off the bottom after everything has melted under the heat gun. We will need the third hand for removing the solder. So you could use the solder braid again and melt it and try and wick up all that solder. It can be a little trickier when it's in this through hole though, because it goes all the way through the board. So we have another tool here. It's this little desoldering pump. And so how this works is you push this little handle down, that primes it, and when you push this button, that'll shoot back up and it pulls a vacuum that sucks on the tip here, like that. If we remelt from one side of the board and place the solder sucker on the other side of the board and then push that button, when everything's molten, it'll suck all the solder right out of that hole, and then you can put your new component in or do whatever you need to do. I've primed it already, and I'll remelt on one side. Okay, so it's molten. I'll take this and I'll place it on the other side of that connection pretty firmly, and I'll push that button, and just like that, it pulls all of the extra solder that was clogging that hole right out.
Okay, so you push that down, and then, you heat it up from this side, you said? You're gonna hold that there. Oh, good night.
It looks like it didn't quite get melted yet, so
probably because I jerked it away.
what you can do is kind of take the corner, the sharp corner of that chisel tip, and rest it in that pocket, so you got something kind of tactile you can feel. Okay. And you'll be able to see it from this side when it melts.
Oh, okay, so do this first before holding it up?
And then just make sure it's held on there the whole time.
Wow, this is hard.
It takes a bit of practice.
This was harder than literally everything else.
There it goes, it's starting.
Oh, I have to hold that.
You gotta keep holding it, no worries.
And see this, you know what? I thought the soldering part would be the difficult part.
That's the thing with soldering. Making a joint is quite easy.
This is hard.
Repairing one can be a little trickier, but it's not too bad.
Oh wait, so it's good?
So it's melted, yep. There you go.
Did I do it?
You got it.
Oh, thank goodness.
And it can take a bit of trial and error, and as you try and try, sometimes that flux will start to burn away. So you can add more flux onto each side of it, or you can even, if it starts to get really bad, add a little bit more solder which sounds counterintuitive, but it adds clean, fresh solder into the mix, adds more flux through the core inside here, and it can just help things flow better again. Because when it's just like that last little bit of solder, sometimes it's really hard to get it to melt and come out cleanly. So adding a fresh bit of solder can sometimes help in that situation.
All right.
But good job. That is the basics of soldering.
All right, everybody, that was it. It was actually way easier than I thought it would be. Big thanks to Jonah for coming and teaching me. If you have any questions that weren't addressed in the video, or maybe you want a more in-depth answer, then go ahead and leave us a comment and let us know. Maybe we can come back and do a Q&A video. If you like tutorials, then go ahead and leave us a like on this video. It helps us get an idea of what kind of videos you guys want to actually see. If you enjoy our content, then go ahead and subscribe and turn on your notifications. That way you don't miss any videos going forward. Thanks for watching, and we'll see you next time.